Today we will deal with one of the example of two-dimension motion. And first application is projectile motion. Let us see what is the basic concept of projectile motion. You know that for a curved path we required a force, and here the force becomes gravitational force. That is, gravitational force becomes weight, and weight is mg. It is towards always ground, downward. So in throughout the projectile motion there is a force which is weight, and it becomes mg and towards downward, or we can say minus y. In this case, one thing we should know that when such condition is that when force does not change its direction and magnitude, then we will resolve our all vector quantity along the horizontal and vertical direction. Why? It is simple that when we resolve, suppose there is a acceleration in x direction and there is no acceleration in y direction. So x direction will have acceleration, so they will deal with all equation of motion, whereas in y direction we will simply use displacement is equal to velocity into time. In projectile motion we deal first horizontal projectile motion. For this motion, we have to project our object from certain height. Let that height becomes h. And we project here in general horizontally with velocity v. So we know that in projectile motion there is only a force that is towards downward, and that is gravitational acceleration g. G is the acceleration due to gravitational force. What shall be happen? Now we will resolve our motion in two dimension. One becomes x, another becomes y. Now question is that why you choose downward, y direction? It is due to when it is move, definitely it will move downward. So we will take downward becomes positive y. In such case, first thing, we will treat this motion in two parts. One is horizontal, another is vertical. Let us start horizontal. Motion in x direction. For this, we choose this becomes origin. So our x0 is equal to 0 because start from origin. Next, vx0 becomes v, and there is no acceleration in x direction. So the displacement xt is equal to x0 plus vx0t. We know that vx becomes v, so it is x0 is 0, and that is v into t, and that becomes x. So we can say that there is an equation x is equal to vt, or we can say t is equal to x upon v. This is equation number 1. Now come to the next point in y direction. In y direction there is an acceleration due to gravity. Let us start. y0 becomes 0 because it starts from origin. vy0. Initially the object does not have velocity in y direction, so it becomes 0. Now, but the acceleration in y direction becomes g. We can confuse that y becomes positive g. Why not be minus? So its answer is that we taken positive y direction is downwards and gravitation acceleration is also downward. So both are in downwards direction, so it will take positive. Now we can write yt becomes y0 plus vy0 plus ay t half ay t square. Now we put the value. So y becomes 0 plus 0 plus half plus gt square. Now we have a simple equation y is equal to half gt square. This is the second equation. Now certain definition. First definition is time of flight, means when the body reached to the ground. Definitely when it reached to the ground, the final y direction position becomes h because it comes to the ground. And in this case, if I put this value, then h becomes half g. In place of small t, we will write capital T because it is a spatial time that is called time of flight. So if I write t becomes, then it is 2h upon g and root. This is called time of flight. What is the name? What is the meaning it? In this duration, the object will move, and when it comes to the ground, its time becomes capital T. This is the time of flight. Now, what is the horizontal range? Let us come to the same diagram. This is the tower of height h. Particle is projected from here with velocity v. Now it moves like this and come to the ground. This is called horizontal range because in x direction. So for this point, this x direction distance becomes xt. This is the horizontal range. Now we put this value in the equation, and that equation becomes same thing we can cut it. So xt becomes x0 plus vx0 t plus half ax t square. Now we put the value here. That become horizontal range. You can write r also. This becomes 0. This becomes v, and it becomes t. Now we put the value of t. So definitely it is v under root 2h upon g. This is called range or horizontal range. This is the second one formula that is useful. So first one is that time of flight. This is equation 3 and that is equation 4. This is the thing. Remaining thing is very important. Those are not actually book strict. That becomes velocity direction. So when I say velocity direction, it means It is a angle. Whenever I say direction, you should be know that the direction is nothing but angle. An angle between two lines, not one. So when I say the direction of velocity, so you have to refer that whether it's from x direction or x-axis or y-axis. Mostly we treat velocity in respect of x direction. So, so when I say the direction of velocity, it becomes angle and tan theta. Here put I suffix x because you should know that this angle is between x direction and velocity. And this is the velocity in y direction after time t, and this is the velocity in x direction, sorry, in t. But y direction velocity is, yes, 0 plus half, sorry, 1 gt. V is equal to u plus at. And this becomes v. It is initial velocity, x direction velocity, you should know that there is no acceleration. So whenever I ask velocity in x direction, that becomes v. It does not change. So we can write this one, gt upon v. This is the direction of velocity. Second thing is that energy concept. What is the velocity when particles reach to the ground? There is two things. One, we can treat that velocity at ground means velocity after t capital T second, it is root of vx t whole square plus vy t whole square as per vector. Sorry, this is wrong. And this is capital T. But it will also give the same answer. We can treat work power energy also. Work power energy says that energy of the particle is gravitational energy and mgh. It converts into kinetic energy half mv square. From this we can find the velocity. So what is the velocity? We can cut this and velocity becomes under root 2gh. From this equation also we can consider, but it is so easy. So why should we go in tough method? If it's not possible, then we will use that one also. Let us start. This is the fundamental things. So what are conclude for horizontal projectile motion from a certain height? Very important thing that in x direction, you should use this concept. In x direction, velocity becomes constant. Means velocity at any time becomes v. Second, velocity in y direction. This is velocity in x direction. So, when I say y direction, in y direction there is a vertical motion. There is a formula, but another thing is that yt is equal to gt. So, it is very easy. In y direction, velocity after 1 second is g, that is t. Velocity in y direction after 2 seconds becomes 2g and it is 20 because g becomes 10. So in this way, it is very easy when I say, suppose I take an example of that. Let this is the tower of height 100 meter. A particle is projected with velocity 20 meter per second. Now, what shall we do? We calculate all parameters. Let what are that? Time of flight. We know that it becomes 2h upon g. So we put 2 into 100 upon 10. So root 20. One thing you should know that when you solve problem, don't be concentrate on the calculation. You go on physics only. No meaning to calculate this root of 20. It is simple maths. You can calculate in 6th, 7th class. So it is not our target. Second thing, range. We know that horizontal range, that velocity into time. Velocity is 20 and time is root 20. Yes, one thing is more. You should write proper units. This is in second and this is in meter. You should write. This is the two things. Now, one thing question, when particle strike to the ground, what is the direction of velocity? So we can say that tan theta with respect to x after time t. So what shall be? Velocity in y direction in velocity in x direction after time capital T. It is nothing but gt upon v. That's simple. So this is called a simple concept of horizontal projectile motion. Yes, this is the example. So we will go in next article about angular projectile motion. What means of angular projectile motion? When we project object neither in x direction nor in y direction, but between x and y direction or horizontal and vertical. So, all right. Next time we will start with angular projectile.